This is Mechanical Science Sheet 4, question 3. So we have two pivots here on the ceiling. One holds up a rope and the other holds up a beam. The beam and the rope are connected in the center as shown here. So the first part of this is working out the torque due to the mass. So if we look at the mass here, it acts at the center of the beam and it acts downwards. So that's something we're used to. But one thing I want us to have in mind is when you have a mass and it's held at an angle like this, imagine it being flipped over. So that arrow represents the direction the mass originally, sent its force into. So it's downwards. If you rotate the mass by 180 degrees, then that arrow points up. So that doesn't necessarily mean anything on its own, but I want you to think now about something like this, a beam with the same point on top. If you have it facing upwards like that, and you say that's 0 degrees, if you rotate it by lifting one end by 30 degrees, you suddenly have 30 degrees below and 30 degrees on top. And if you imagine a line going from this beam straight downwards, that angle of that beam would be 30 degrees away from its normal, if that makes sense. That sounds quite complicated, but the long and short of it is, in situations involving mass and when it's been rotated in such a way, you can literally just use cos. So for this one, we would say mg multiplied by L divided by 2 multiplied by cos 30 is the torque due to the mass.